Should be able to see my screen now. And hi, Abby. So let's see Sarah's first question. I'm confused about Unit 5, Lesson 2. When we're finding equivalent expressions, how are you finding them? So basically, let me pull up because a student earlier had asked me on Tuesday the same question. And so this is like an example I went through with them. And so if the question was to find the trig equivalent ratio of sine 30 degrees, basically, you can see my screen okay, right? Perfect. Okay. So when I'm dealing with sine 30, there are a couple of things I'm looking for. I'm looking for my angles that also have the same related acute angle of 30 degrees in the different quadrants. And I'm also looking at CAST, C-A-S-T. I highlighted these in blue to indicate that that's where my trig ratios are going to be positive for the one I'm interested in, because that's where all and sine trig ratios are positive. And so for sine 30, what I'm doing is, okay, I'm drawing these 4 lines to indicate that these will all have a related acute angle of 30 degrees. And we saw from a previous note that I think it's Unit 5, Lesson 2. So busy right here. Right here. That all of the sine trig ratios with the same related acute angle, the magnitude, meaning the value of each, are all the same, except the signs are different. And so when I go back to the side notes, my first equivalent trig ratio to this example is so I think I wrote sine 30. It got erased. So sine 30 which has a value of 0.5 on the calculator. So the very first angle that I got that also has a related acute angle of 30 degrees is 150. And so this is my first equivalent trig ratio. And because both of them are in my blue highlighted part where it's under CAS and they're all both positive, I did not need to change the sign of the value in front of the trig ratio. And I was able to leave it at that. When I go to the next one, so I kind of work my way counterclockwise. So I found my first one, and then I drew this black one. And I noticed that sine 210 degrees also will have the same trigonometric ratio, but because it's not going to be positive here, because this is where tan is positive, I had to put a negative sign in front of this to ensure that they do in fact equal. And so on my calculator, what I'm doing is sine 30, and that's equal to 0.5. And when I do negative sine 210, I will get 0.5. Because otherwise I would have gotten negative 0.5. Well, how am I going to make it equal? The easiest thing for me to do is put a negative sign in front of that. So I basically went through 1, 2, 3. So 2 equivalent trig ratios to sine 30. Are there any questions regarding that? Are you able to see why negative sine 330 is also an equivalent trig ratio? So following along, all these 4 angles have a related acute angle of 30 degrees. So this is the other angle that has a related acute angle of 30 degrees. So it's 330 degrees. But I had to write negative sine 330, and I couldn't just write it as sine 330. Okay, perfect. Okay, awesome. So you're understanding it. Are there any follow-up questions? Any more questions from you? Yeah. Let me know a question that you didn't get. So is sine 150 degree a related angle? So sine 150 degrees is it is like the related angle that has the same related acute angle of 30 degrees. Not sure if there's like a formal word for it. But 150 degrees also has an related acute angle of 30 degrees. Okay. For the next question, lesson 2, question 30 from the second handout. I have to pull it up for a sec. And Sarah, go ahead and you can type up any questions you have. I know Abby said she has 2, and then I'm not sure how many questions you have, so. Abby, is your question that says sine negative 2 pi and what the value of that is? Is that your question? Abby's question, code 580. I'm going to first deal with it by, I don't want to write it in terms of 580 because that's not in standard position. So first thing I'm going to do is write it as cot 220 degrees. So what I've done is I'm subtracting 360 degrees because if you are on the X and Y axis, if you're drawing 580, that's from this initial position, that is 360 degrees. And then I would go another 220 degrees and I would arrive somewhere here. So by me actually giving you a coterminal angle, that's one version of an equivalent expression. So this is using coterminal angle. So Abby, does that first part make sense? One way that we could find equivalent ratio, and one of the easiest way, is to give them a coterminal angle, because coterminal angle just means that it's going to have the exact same terminal arm. So that is one acceptable way of finding your equivalent ratio. Okay, so the second part, so another angle, I'm seeing from the solution, cotangent, same side, and third. Okay, so the other way that you can do this is, I'm gonna write the cast to remind myself, and I'm dealing with tangent because cotangent is the reciprocal of cotangent, and so I have tangent and A. So what they're doing is that, okay, that's one. And what is a related acute angle for this? So the related acute angle for this is 220 minus 180, which is 40 degrees. And that means I can draw another arm over here. And this can also have a related acute angle of 40 degrees. And so what I'm doing here is that if this is cotangent 220, I could also write cotangent of 40 degrees as my answer, and they will be equivalent because according to Cass, well, they're going to be the equal values because we're dealing with the same related acute angle and it's the same sign. So another version that I might come up with is writing cot 580 degrees is equal to cot of 40 degrees. And that's because I think the solution tells you the reason, but cotangent has the same sign in quadrant 3 and quadrant 1 by cast. So there's, I guess, there's a couple ways of getting it using coterminal angles. That's one of the fastest ways, because then you're doing adding or subtracting of 360, or you are looking at the related acute angle and then carefully telling me the equivalent ratio. Okay, Abby, I hope that makes sense a little. I'm gonna go back to Sarah's question. Okay, we'll just take turns. Sarah was asking me about the dropping the negative. I agree, that might be confusing. I'll tell you the reason why we're doing that. Okay, so over here, Sorry it's so messy. Well, it's not messy, it's just really colorful. Maybe a little too much. But here I tell you to drop the negatives when you're trying to find the related acute angle. So, okay, perfect. So if you don't take the negative out, I mean, it's still very workable. But I want to keep my steps kind of consistent when I solve. And so one way I'm doing this is I'm dropping the negative, and that way I'm getting a related acute angle every time rather than, let's say, an obtuse angle. So if I take the sine inverse of positive 2 over 5, I get 23.578, so about 24 degrees. If I do sine inverse of the negative, I get negative 24, and it's really kind of telling you the same thing because you're going now from your initial position and you're going that way. So for this question in particular, I mean, it makes sense both ways, whether you drop the negative or not. And the only reason I'm just kind of trying to be consistent with the drop being the negative is if I take cos inverse of negative 0.5, I ignore the dropping the negative part, I'm going to get 120 degrees, so an angle right there. And then you have to work with the information and go from there. And then you have to say that the related acute angle is 60 degrees. So can you see how if we don't drop the negative, we might come across situations where we're not finding the related acute angle. Sorry, I cut out. Yeah, exactly. And so basically, drop the negative, find the related acute angle, and you are going to use that related acute angle. And then this question, it said that sine theta is a negative, which means y is negative. That means when I draw my arm, I'm considering that negative part, and then, yeah, I'm applying the negative afterwards when I'm drawing my terminal arms. So I know you said that it kind of cut out. Am I saying everything that you kind of need to hear? Is that making sense? So drop the negative, find the related acute angle, just so that you can find your related acute angle. And then you are going to consider the negative when you're doing the actual drawing so that you know which quadrant that it is properly in. And then once you draw this arm, I mean, you can go straight to here pretty quickly, but I just want to tell you how, like, the order of how it goes. So you find that, and then you're going to be able to find your angles accordingly. All right. So is that all your questions for you two today? Anything else? Yes, go ahead. All right. Abby, you can either stick around or you can listen in. So what's your question, Sarah? And are you two okay if I just save this recording and post it so that students can see it? Okay. How about you, Sarah? Okay, perfect. Okay, so that way I don't have to edit it and stuff. It's 7 in the Unit 5 Lesson 2 handout. Okay. Okay, number 7. To confirm your question, is it the one that is like negative 43 pi divided by 12? That one? Okay, so you said Unit 5, Lesson 2, number 7. Maybe I'll take a quick screenshot. Is this the question, Sarah? Okay, perfect. Okay, so one thing is they're telling you it in pi mode, and we just have to replace it with 180. So let's do that first. I'm going to use my calculator to reduce. So it's telling me it's a negative 645 degrees when I do that. And I have to look back and see what the question was asking. It says state a list of coterminal angles. Pick out the principal one. and name the related acute angle, predict if sine, cosine, and tangent will be positive or negative. Okay, so basically when we have negative 645 degrees, I want to make sure it's in standard position. And so first step I'm going to do is second step I'm going to do is I'm going to try to add or subtract by 360. And in this case, it makes most sense if I add by 360, probably 2 times. Let's see. If I do that, I get negative 285. And if I do negative 285 plus 360, I'll get 75 degrees. So that is my principal. And so 75 degrees is my theta. Okay. Okay. So that's my theta, but they were asking me to find the couple things, coterminal angles, right? So theta 1. Okay. So I know that the solution is telling you in like the radian form, so it might be confusing you. So theta 1 is 75 degrees. If they want me to tell them what my coterminal angles are, then I'm just going to add by 360 and subtract by 360. That's going to be the easiest thing to do. So let's see, 75 plus 360 is 435 degrees. So that's my main angle. That's a coterminal arm. Theta 3, I could have done 75 degrees minus 360. And I get negative 285 degrees. Okay, so these are some lists of coterminal angles. You're basically adding or subtracting 360. So I've answered that portion right here. So that should be okay. And then the other thing that they asked me was to predict whether sine, cosine, and tangents are positive or negative. Well, you notice that basically according to CAST, C-A-S-T, that all ratios are going to be positive over here. All positive over there, right? And so that means my sine and my cosine and tangent is going to be all positive. Okay, so what does that mean? Well, that means that for sine is my y, so my y is positive, and my cosine, my x is positive, and my tangent, my slope is positive. So, okay, bye, Abby. Yeah, for sure. The radian would also throw me off. The way you can look at it, because I know the solution is telling you radian mode. If you know how you see in your solution version, it says 5 pi divided by 12. Yeah, it's 5 times 180 divided by 12. So if you write any of these things and you just plug in the 180 in terms of pi, then it's gonna make more sense. So like when I plug in pi as 180 for negative 9 pi divided by 12, I get negative 135 degrees. Okay. So I'll upload this solution to the homework consolidation. So the coterminal angles don't have to be in the solutions form. What does that mean? So the coterminal angles don't have to be in the solutions form. Can you expand on what you mean on that? In the solutions form? Like in a fraction. Oh, okay. Okay. So you know how in the solution, they're telling you this list of coterminals in radian form. So negative 67 pi divided by 12, negative 43 pi divided by 12. They're doing that and they're writing in fraction form just because of like the way the numbers are kind of laid out. But when you are in degree mode, you're not really gonna have any fractions involved. It's mostly gonna be you're right, like whole values or maybe sometimes decimal. But yeah, you're not gonna really have decimals when you're in degree mode. Yeah, so that's a good question. Okay. All right, sounds good. See ya. Have a good weekend. Bye.